So the M12 threaded rod cuts short, a hole drilled through it, and there's a pin which keeps the threaded rod inside the U-joint that comes up through the bottom plate, held with this M12 nut. The whole assembly is held together with this M8 threaded rod and M8 nuts. This is aluminium and 6mm, and it's 130mm square. It was cut with a timber saw, which didn't seem to do any damage. It was cut. A friend cut that for me, but there can be you can get that cut at the local aluminium store. Now the main component before you start thinking about building something like this is the motor itself, and this sets the stage for the actuator dimensions and a lot of other aspects of the actuator itself. This one is a Motion Dynamics 450 watt 24 volt motor. It has a fan, built-in fan, which draws the air through the motor and then expels it out the bottom. Keeps the motor cool. I haven't found that the motor gets warm, so it must be doing a good job. Why this is important is that the flange which the motor is constructed with is fairly large, and the screws which attach it to this plate, the flange threads don't go all the way through, so it wasn't possible to make the plates a little bit bigger than this flange. So I've made the plate just slightly bigger than the flange and still have some structural integrity for these threads to go through. The motor also determines what kind of driver that you'll use. If you choose something with a very high current, so more than 32 amps, you'd have to go to a Sabertooth 2x60, so an added expense, but the main thing is you're going to have to add these batteries, take up space and more cost and so forth. So choosing the motor is absolutely critical. The motor is connected to the lead screw via this motor coupler. It's called a Plumb Coupler. Now it's aluminium. These are polyurethane teeth which hold the two ends together. You can actually pull them apart. The main strength is of course rotational, held together by two very thick grub screws, one on the motor and one on the end of the lead screw. The shaft of this motor is 17mm and the shaft of the lead screw is 10. So I had to find a coupler 17 to 10 and it wasn't easy to find. But the thing with this motor is the side view, it gives you the dimension across the flat face where the grub screws would normally go, and that is quite a few mil less than the actual diameter of the shaft. So made that mistake and had to buy another set of these couplers. The bottom bearing is attached to this bearing plate. It's held with a nut to stop the lead screw from coming out of the bearing itself, and that in turn is held by a small grub screw. So this is the bottom bearing. Bought that at the same time as the lead screw, and this is the ball nut. Oh, actually just underneath here, that's the ball nut there. So this is a 16mm diameter lead screw and a 5mm pitch on the thread, typically used for CNC machines or printers. It's attached by these 4 bolts. The lead screw and ball nut, this assembly, which is the rod assembly, is bolted to the ball nut, and the rod is pushed up by the ball nut, and that's what gives you the linear motion. The whole assembly is held together principally by these M8 threaded rods, but also by this 60mm V-slot aluminium extrusion. This comes from the open build community. I got it from a local supplier. It wasn't Wasn't terribly expensive, very easy to cut, aluminium, just cut it again with the saw, with a drop saw. It's 500 mil exactly, and it's critical that you cut this square, otherwise it makes it difficult to get the whole assembly at a 90-degree angle for the lead screw, and you'll end up with the rod being off center and it will rub on the inside of the rods. I'll explain the feedback pot when I do the electrical part. The limit switch, there's two with a lever. These provide the limits for which the ball nut can either be at the top of the travel or at the bottom. The limit switches are set at the lowest point that will safely allow the motor to not hit either the bottom or the top of the actuator. The reason it has to be this distance away is that the gravity and inertia will drive it past this limit switch, and what you don't want to happen is for the ball nut to hit the bottom of the bearings. It won't be powered at that point, but it can hit it quite hard. The downside with this is that the limit switch will limit the travel of the actuator rod. So if you have them closer together, if I move this up here, it'll be a lot safer, but there won't be as much travel on the motion platforms. So there is a trade-off with the position of the limit switch, and I'll speak more about the limit switches later. The 3D printed assembly was the piece that I probably wasn't as happy with the rest of the build. It's been printed out of PETG 3D filament, that's 60% infill. It's quite hard. The problem I think I've had with it is that there's three pieces. There's the anti-rotation part here, the rod holder, and then the rod sleeve which fits in top of that, which meant that when it was being put together I had to epoxy each of these things together, and on one of them it wasn't quite square. You can't go back once it's epoxied. So I think if I had a chance again I would make this as one whole piece. There's an additional piece here which was screwed on. Whether you could make this as the whole piece or not I don't know, but this is the arm which hits the limit switch. So as it moves up it'll hit this limit switch. The epoxy is 3M. It was quite expensive, but what makes it good is it's very, very slightly flexible. So it's not brittle like, say, Araldite and other epoxies. Super, super strong, and has really performed the job really well. And it connects to this carbon rod, and carbon rod is 500 mil. You'll see some of the details for that and where I bought it from in the build thread. That passes up through this top plate, again 6 mil aluminium, and the linear bearing. Again, this came from AliExpress, most of these bits did, and you'll see the links in the description of my build thread. So there's a 30 mil hole as it passes through here, and then up. Again, 3D printed part which has been epoxied into the end of the carbon rod, which connects to this rose joint, and the rose joint joins the frame and is sandwiched between these two wheel nuts. I bought a cheap tap from eBay and rethreaded these so that they would match the thread of the M12 bolt. This is a stainless steel bolt. Again, a nylon nut to stop the unscrewing, but very stable, and that part's worked really well.